Okay, so in the previous lecture, we have seen the Web API framework, its architecture, and how the HTTP request message flows through this architecture, which follows the design pattern called pipeline, and it is processed by different component, and then finally it is converted to the HTTP response message, which is sent back to the client, which is again passes back through the pipeline architecture. So in this architecture, one of the important component is message handler. So the purpose of the message handler is to pre-process the data, validation purpose, and sometime authentication purpose also. So or more globally for logging purpose also. So we'll see the purpose of or use of the message handlers in the Web API framework. And then we will also see how to write our own message handlers and incorporate into this pipeline architecture. So let me share the slide. So basically they are called as the HTTP message handler because they handle the HTTP request and response. So if you look at the initial part of the architecture, what we are getting, the actual HTTP request coming from the client will be handled by the HTTP server, and it will convert it into the strongly typed HTTP request message, which is passes through the different phases. So first it will be encountered or handled by the delegating handler. So this delegating handler is nothing but an example of HTTP message handler. It is an example of HTTP message handler. The basic idea is to get the request. It can pre-process the request and it can also post-process the response. Okay. So that is the main idea. What you are getting, the request is coming. Here you have HTTP message handler, and then further it can pre-process the request and it can send it to the further in the pipeline. From the pipeline, we'll get the HTTP. From the pipeline, we'll get the HTTP response message. From the pipeline, what we'll get? We'll get the HTTP response message, and then this response message can be processed by this HTTP request handler, and further it can be sent back to the client. So this is basically the flow. Here you can have one or more message handler. That is possible in the pipeline. You can insert one or more message handler, and even we can devise our own custom message handler. So in this architecture, delegating handler is an example of the built-in message handler, which can take the request message and it can also process the request. But usually now it would be simply forwarded to the next phase or next architecture, next phase in the pipeline. Then comes the HTTP routing dispatcher. It is also an example of HTTP message handler. Okay, so there are three. Delegating handler is a HTTP message handler. HTTP routing dispatcher is also HTTP message handler, and there is one more. This HTTP controller dispatcher is also an example of HTTP message handler. So what happens here? This will be basically the role of this class is to decide the route, and based on that route, it can determine the controller. Okay, so normally we define the route. Okay, suppose if we remember that this is the route that we are used. Okay, for this particular route, this is my pattern. So if my route is API2/controller/ID, what we can do, we can specify the message handler via this property handler. So far we have not used this. So the use of this one more property called handler is to devise the custom message handler to insert our custom message handler in the existing pipeline. So whenever we insert our message handler, it would be invoked only for that particular route. Okay. If this is the path name in the URL, then only this message handler will be invoked. So it will be added in front of our or before our controller. So what will happen? You will see that it will be added just before our controller. Okay, so this is my custom message handler. This will be the controller code. Further, within the controller, we can have the action methods. So that is the role of the message handler, and you can insert one or multiple custom message handler. That is possible. Multiple message handler can be added. That is also possible. So if suppose we are not doing this, that means we are not inserting custom message handler, and the route specific, it will identify the controller. Based on that, further it will be moved forwarded to this HTTP controller dispatcher, and the job of this HTTP controller dispatcher is to based on the controller in the which is defined in our route, it will invoke the controller, and within that it will determine the action method based on the get request or put, post, delete, and that particular action method will be executed, and whatever the response message created by the action method, that will be written. So once again it will go back into the pipeline. Okay, it will go back in the pipeline. Okay, then once again from here to here, here to here, finally that HTTP response message will reach to the server, and that server will send the convert it into the HTTP protocol response message. So this is the flow. Is this flow clear in the architecture? What is message handler? What is its role? The default, some of the built-in message handlers are there, and we'll see that how to write custom message handler and add it to the existing set of message handler. Within the pipeline, how to add our own message handler. Up to this, it is clear. Any doubt you can ask. Hope that I am audible to all of you. So, in fact, this HTTP message handler can be of broadly of two types. Can be per route message handler or global message handler. So if we define something like this within the route, if we specify our own message handler, then it would be per route message handler. And there is also another way to add it globally. So it will be become part of your delegating handler. We'll see that how to do that. Like we have added the action filter. Similarly, you can add it to the collection of the global message handler, and you can make your custom handler as part of the global message handler. So they will be added in this pipeline. So right now there is only one, but we can add our own. So see that this is an example. So first of all, we will work on the example and then we'll go into the code. So what we are doing here, see that this is the HTTP server. The request is coming from the network. Here in this example, two message handlers are inserted. These are two custom message handlers, say 1 and 2, message handler 1 and message handler 2. These both are custom, that is user defined. The remainings are inbuilt, HTTP routing dispatcher and HTTP controller dispatcher. So see that ultimately what traverses, the HTTP request traverses like this. Finally, it would be at the controller level. It will be executed by the appropriate action method, which will generate the HTTP response. That will once again go back into the pipeline and finally reach to the HTTP server. So this is a simplified view, and you can easily understand from this diagram what's going on. If it becomes difficult to understand in this diagram, then you can this simplified diagram will help you in understanding the role of the message handler, and even you can understand that you can have custom handler which could be one or more multiple custom handlers. It is not necessary that only one message handler. You can have one or more message handler. You can insert into this existing pipeline. That means the current architecture is extensible. So say one message handler is used for validating the data. Another message handler can be used for logging purpose. Third message handler can be used for say authentication purpose. Likewise, you can for basically for different cross-cutting concerns, you can write down your own message handlers. And sometimes even suppose the data is not validated, simply you can do short circuit. That is also possible. What is happening? Suppose request is coming and the data is not valid, then you can simply do the short circuits, immediately send back the response to the back, so that it will not go into the pipeline. It will not be further redirected into the pipeline. So that time is saved. This much time is saved. I hope that this is clear, the benefit of message handler and the working of message handler. What are the benefits and applications of message handlers? So first we'll understand the concept and then we'll jump into the code. So this is further, this diagram is further simplified, that HTTP request is coming and this delegating handler will invoke it. Then the job of this delegating handler is to further redirect it to the inner handler. So inner handlers are nothing but any further message handlers which are defined by the user. Okay, so here this as an inner handler, you can have one or more message handler in the pipeline, like we have seen, message handler 1 and 2. So suppose this is inner, usually they call it as an inner handler. Then it can be further, then the response will come. Then again, it can be response can be generated likewise. So to achieve this, what we have to do? We have to derive our custom class from this delegating handler class, which is part of this namespace system.net.http. So derive the custom class from delegating handler. So see the name delegating handler, because it delegates the job to the inner handler. That's why the name is delegating handler. And the further pre-processing or post-processing of the data can be performed by the inner handler. And what we need to do, we have to derive from this class and override this send async method. So as the name has the suffix async, that means it is an asynchronous method which takes request as the parameter, so that you can pre-process the request, and finally it is returning the HTTP response message as a task, because it's an asynchronous operation. It's an asynchronous operation, that's why it returns as a task. So it uses the task parallel library. And second parameter is cancellation token. This is required in case you want to cancel the task. So right now we are not using it, but in general, whenever you are dealing with the task, you can cancel the task, you can store, you can wait for the task, like thread. All those operations are possible. You can return the data from the task. So what are the steps? Usually what the message handler will perform, it will process the request message. So it will do some processing. It can read the header, it can validate the header data. Once that is done, again it is optional, not mandatory. Then it can call the base.send async, because now here it will further call the base.send async. So there might be further message handler in the pipeline. So we need to call this send async, because it will be further redirected to the next level of message handlers in the pipeline. So this will be redirected the request to the inner handler. Once the inner handler processes, it will give the response back to the our handler. So it will give the response message as a type HTTP response message. And this step is asynchronous because it is an asynchronous operation. And finally, we can further process the response, and whatever the modified response can be sent back to the caller. So basically, it can be another inner handler or it could be delegating handler. So this is the job. So within our API project, what we'll do, we'll create our class my message handler. Okay, what is the question? What we are doing in custom inner handler? This is our inner handler is our custom handler. This is my custom handler. And see that, suppose if we remove this, then we have not written any handler. But suppose we write our handler, then we can further redirect it to the next level of HTTP message handler. Suppose we have written only message handler 1, then it will be further sent to the HTTP routing dispatcher. Is it clear why we need to call base.send async? Inner handler is our custom handler. This is just the name. Inner handler is our custom message handler. It is just the name. And the task I told you, like you can log the data, you can validate the data, you can look for some header value. All those are the tasks that we can perform in our message handler or custom handler. So inner handler is just the name. Remember, this is just the name which we give to the custom message handler. And there could be one or more inner handlers. Okay, like in this diagram, there are two custom message handler, but it could be none also. So far, we have not written any. So there is no message handler. Simply, you can think of this figure like directly this HTTP server is sending the request to the routing dispatcher. And then it would be sending to the HTTP controller dispatcher likewise. So we create this. Sorry. We create the my message handler 1, which is derived from the delegating handler, and it is part of this namespace system.net.http, and we will override this method send async. The signature we already seen. It takes 2 parameters, HTTP request message and cancellation token, and it returns the HTTP response message as the task, and it is an async. That's why it's an asynchronous method. That's why we have this async keyword in front of the method. Okay, now can you tell me what it is doing? You can just read the code and tell me what is done by the custom message handler. Okay, anything else? It calls the next inner message handler. Anything else? Okay, so see that here we are not doing pre-processing, we are doing post-processing. So normally we'll see that in this diagram, when we get the request message, we can look into the request, and once we are getting the response, we can also process the response. But in this current code, we are not doing any kind of pre-processing. We are simply manipulating the response message, which is coming from the inner handler, and then further this modified response is further sent back in the pipeline. Okay, in the pipeline. So what we do, we don't do anything. We don't modify the request. Simply we are calling base.send async. Okay, we are calling base.send async, simply passing the request and cancellation token as it is. Okay, not manipulating them. And because it is an asynchronous operation, we apply the await keyword, and it will return the HTTP response message. Now, this response message headers, we add our custom header with this value. And finally, this updated or modified response message is sent back in the pipeline. So basically what happens, everyone does this. In the pipeline, the job of every phase is to get the request, process it if required, otherwise pass it to the next phase. So this is usually done in the pipeline. Okay. Always what happens, the request is coming, it can be processed, it can be further request can be sent to the next. And this is what happens. Once at the very last stage, it is the action method that will be executed. It will send the response. Further, it can be modified by this phase. Once again, this modified response will come. Again, this can be modified by this, and this modified response will be sent. So this is the flow of the message handler. So right now we are not doing any kind of pre-processing, but we are updating the response. Now, how to add it to the message collection of message handler? So within your this static register method, we have this HTTP configuration. We have config.message handlers collection. So add this instance of my message handler one. Add it to the collection, and this way you can add multiple message handlers also. Suppose dot add new XYZ. Okay, another message handler. Dot add new PQR. So multiple message handlers can be added to the collection, and this would be executed in the order in which they are added to the collection. So what happens in the pipeline? This is the first message handler, then second, then third, and so forth. Finally, it will send to the next level. I hope that it is making sense. Now from concept to implementation, how you can do it in your code, how you can add the new handler, custom handler. You can specify whether to process the request message or header of the request message. So your request HTTP request message is consisting of two parts, header and body. So you have control over both the entire request message. Finally, once it is coming, there is you can also have the control over the entire response message. So now suppose this is the request. This gives the static list of 3 products. We get the response 200 okay. But now if you further look at this response header, okay, within that you will find out our custom header. This is my custom header. So this is just for testing purpose, how we can modify the response, or you can modify the request as well. Okay. Is it clear? Any doubt so far? Okay, so my question is, let me remove this mess. Okay. What if I remove this line? What will happen? I'm not calling base.send async. in my message handler, what should happen? So inner handler in our pipeline will not be called, but then do we need to modify this code, or simply by removing this line it will work? Basically, it is short circuiting. Okay, the entire further phases will never be executed because we are not sending the request further in the pipeline. But here we need to create our custom response message. We can create custom, say response equal to new HTTP response message and content equal to, say, something like this. Write down, say response equal to new HTTP response. And further, you can set the content to new string content, hello, kind of thing. And then finally, you are sending the response over here, return response. Okay, so this is the what you have to do. Basically, you have to replace this line with your custom response message. So that is the modification required in the code. So what will happen every time there is a request? Always the response will be hello. Okay? Always the response will be hello. So if for any request there will not be any output, only there will be hello. So this is what we mean. Okay, one more example of custom message handler. Can you guess what it is doing? Just go through the code. It is self-explanatory, but still I will explain few things. This is my custom handler, what it is doing. So can you tell me what it is doing? Okay, let me explain. See that when we instantiate this our message handler, what it requires some key. Okay, it required some key value. So if the request is coming and that request doesn't contain this key, then the response, immediate response will be sent back to the client that you are not validated. Okay. So this is the purpose of this handler. So how do we instantiate? Suppose we are adding this new API key handler, and now as part of it, we are specifying the key value. Say key value is 1, 2, 3, 4, 5. So now we have added two message handlers. Previously, we have created my message handler one. Now we have created new API key handler with this value. What we are doing here? Do we do pre-processing? Do we do post-processing? Or both? Pre-processing, post-processing, or both or none? Neither pre-processing nor post-processing. What is your answer? See that here, if we are doing something with the request, that means we are doing pre-processing. So what we are doing, we are checking the request message, whether it contains the key or not. So this function, it will, from the HTTP request message, it will try to convert it into the name value collection and look for the key value. Okay. If the key contains our key that is initialized over here, then it will return true. So it does some form of pre-processing. Okay. Now, do we modify the response message? So we create the response message. If it is not matched with the key, then we create the error message, okay, the HTTP response message that it is forbidden. And as the value, we are saying that key doesn't match. As part of the request response message, it will have the message that key doesn't match. And here, this is the class called task completion source. The use of this class is to create a new task. Okay, the purpose of this class is to create the new task, which is an asynchronous. And also, you can also do the, you can complete the task, send the result via the object of this task completion source. And sometimes if you have some method which if you are dealing with the delegate, then you can directly use the task. But if you are not dealing with the delegate method, then you can use this task completion source. Basically, you can deal with it. So what we are doing here, we created this HTTP response message as a new task. For that task, set the result to be this response and return that task, tsc.task. So the purpose of this class, task completion source, is to create the task and manage the task. So this will be done only if we are key doesn't match. If the key matches, then we don't do post processing. Okay, we don't do post processing. Simply send it to the inner handler by calling the base.send AC. Okay, so and whatever is written by this, we are returning. So that means we are not doing post processing. We are not doing post processing if the key matches, but if the key doesn't match, we are not forwarding the request message in the pipeline. We are creating the custom HTTP response message with the status code forbidden, directly returning as a task, because it is the return type is task of type HTTP response message. So I think this is clear from this example, and then we are adding it as the new message handler into the message handler collection. And now, if we use this URL without any key, we do not get any response. Okay, we do not get any response. And if you further look into the developer tools, if you look at the status code is 403 forbidden, because we have not provided the key, API key, as part of the URL. Now, and again, the response message will have the string that key doesn't match. Now, we further what we do as part of the URL, if you provide key equal to 12345 as the query string parameter, and if we click on the send button, what you'll get? The response 200. Okay, and yes, you will get the complete product list. But now see that you should not pass your this kind of key or secret key as part of the URL unless you are using the HTTPS, because on the over the HTTP protocol it is not encrypted, but if you are using HTTPS protocol, it is encrypted. So usually it is not secure. Now we'll talk. These are the global message handler. Now we'll talk about the per route message handler. The trick I have shown you, for some specific route, you add this property header and set it to the new instance of the message handler, and it will be act as a per route message handler. So now see that this, if we add to the global message handler, it will be global message handler. So message handler 1 is the global message handler, while message handler 2 is the per route message handler. So this is as simple. So if your URL path name is this, then per route message handler will be executed. But if it is other than this, then global message handler will always be invoked. Okay, it will always be invoked, because it is getting the request before actually it is passed on to the controller. Okay, so this is route 1 and route 2, and there are based on this, there may be based on the URL path, it might be redirected to the different route. Okay. And we are getting the response. If it is from this route, we are getting the response, and finally it is coming to the routing dispatcher. Then this is the global message handler. See this in code. This is the global message handler. So it will always there. But route specific message handler are, so suppose message handler 2 is route specific. What is the name of the route? Route 2. What is the URL pattern? This. So this is this message handler 2, and this is specific to route 2. And here we are assuming we are writing the code such that it is doing short circuiting. That means it is not further passing it to the controller. So in this figure, you can see the absence of controller. Here there is a controller, but here there is no presence of controller. That means this code doesn't invoke the base.send async. If we skip that part, we are whatever the request message will not be sent to the next message handler in the pipeline. Basically, we are skipping the pipeline altogether. This is one more example. Now you can see that here what we are doing. We are not doing anything with the request. We are simply ignoring the request, but creating our own response message, status code, okay, and the content is hello. Okay. And once again, create the task completion source, set result to be our response, and directly return this tsc.task. So in this example, you will see that particularly there is no statement that calls send base.send async. Okay, there is no line like something base.send async. This line is missing. That means it is something like this. Okay? No controller. No controller. Absence of controller, no controller. Always it will send the same response. Always it will send the same response, which will contain the hello. Basically, the entire HTTP response message. But which will contain the body as the hello. Header, whatever it is, default value. You can also change the header. But currently it is updating the body. So likewise, further if we said if you are calling base.send async, it will be further sent to the controller dispatcher and then finally to the controller. So that it depends upon how we are writing the code. And if you want to add multiple message handler, you can add it something like this. Using this HTTP client factory, create pipeline. By default, you have this HTTP controller dispatcher and the list of handlers. So you just create the list of message handlers. Because all of them are derived from delegating handler, you can create the new delegating handler, and as the instance, you can provide the instance of your message handler. So here, one or more message handlers can be specified. Basically, they will become part of the global message handler, or you can have a pipeline of message handler that you can insert it as the globally, or you can add it to some route. So here, in this particular example, These are added as part of particular route 2, namely. Okay. So that is also possible. Previously, what happened? Per route message handler. Here in this per route message handler, there is only one message handler. But if we want to insert multiple message handler, that is also possible. So this is the, you can create the list of message handler and use this class HTTP client factory dot create pipeline. And there are two parameters. First parameter is the HTTP controller dispatcher instance, and second parameter is the message handler collection. Any doubt in this slide? So see that how flexible it is. Globally, you can add multiple message handler. Per route also, you can define one or more message handler, and again, it is optional. This is optional. It is not mandatory. You can skip this part. So normally we do not, if you don't want to add the per route message handler, we can skip this part. Okay, that is possible. But here, if we include it, then you can have one or more message handlers, route specific message handlers. And if there are multiple routes, remember that their URL must be different. If we go back to the example, here the URL is API, and here URL is API 2. Okay, even though it looks like same, but they are not the same route pattern. Otherwise, it will create the conflict, and it will throw error at runtime. So this is how we create the message handler. We can have global message handler or per route message handler. You can create pipeline of multiple message handler. And how you can, we have seen how to pre-process the data. You can modify the request. You can post-process the data. You can update the response header. You can get the data from the request. You can validate the data. You can log the data. Everything is possible through by writing this message handler. Okay, any doubt you can ask? Question time. And always see that here the controller dispatcher will determine the controller based on the route pattern. Okay, in the route, how do we define the route? In the route, normally we specify the this. Yes, register method is there. We are doing it. Register method is there. It is a static method. Is there? We have to add the code. And if you use some default template, it will already generate some code. But this will not be there because this is the custom message handler. So this code is not present. Further defining the routes and all those code I have skipped. Convention based routing that I have skipped. Only this additional statements are I have just shown in this slide. Like adding our message handler. So this is available in this web API config class, and register is a static method which gives us the HTTP configuration object. So here in this case, in this example, it would be something like this. Here it would be API. How the order in which you will be inserting this message handler, you will create the pipeline. Okay, custom pipeline. This is how the pipeline gets created. And it will be at here. This is the pipeline that we are talking of custom handler. Okay, fine. So if there are no more questions, we'll end today's session.